section 2.5, absolute value functions and graphs. So our objective is to graph absolute value functions. So for this function that's an absolute value, it always makes what we call a V shape. So when you're graphing these, if you do not see your graph making some V shape like one of these, then that means that you maybe did something wrong. So let's go back to some things that we've already learned this year. So we've talked about point slope form. So remember, point slope form is y minus y1 equals your slope m times x minus x1. So let's see something for a minute. If I add this y1 to the other side and solve, I get y equals mx minus x1 plus y1. Notice that this is kind of close to what we have for our new absolute value function. The only difference is instead of y1 we have c, and instead of x1 we have this b value here. And the m is on the inside of our absolute value bars. So for absolute value equations and graphs, we have what we call a vertex on our graph. So a vertex is a point where the function reaches a maximum or minimum point. So if it's at the very bottom, we call it a minimum vertex. If it's at the very top, it's a maximum vertex. So there is a specific way to find the vertex of your equation. It's by using this formula right here. So negative b over m comma c. So negative b over m is your x value and c is your y value. So when I'm graphing these, I like to follow a couple of steps to graph. So the first step that I do to graph, I first plot the vertex, so find and plot the vertex. So find and plot vertex. And then step 2, I pick two x values. To the right and left of the vertex. And then 3, I make a chart or a table and plot the points. So those are the steps that I follow when I'm graphing. So step 1, I'm going to come over here and look at my equation. I have y equals the absolute value of x. So I'm going to find and then plot the vertex. So remember our equations, y equals the absolute value of mx plus b, close absolute value bars, plus c. So in this equation, notice that there's nothing in front of the x. So if there's nothing in front of the x, remember just at 1 x, there's no b value, so really it's plus 0, and then there's no c, so plus 0. So my m in this case is equal to 1, my b is equal to a value of 0, and my c is equal to 0. So to find the vertex, I use negative b over m comma c. So the x coordinate, we use negative b over m. So in this case, my b value is 0, so negative 0 over 1, which is equal to 0. And my c value, we already know, is equal to 0. So then my vertex is the coordinate 0, comma 0. So I'm going to plot that on my graph, which is right here. So then after that, I'm going to pick two x values to the right and left of the vertex. So I'm going to put my vertex on my t-table over here in the middle. So something to the right of my vertex would be the x-coordinate 1 and 2. Something to the left would be negative 1 and negative 2. Now, do you have to pick values that are right next to your vertex? No, I could have picked 2 and 3 or 1 and 3 and vice versa for the negative side, but I usually like to stick close to my vertex. So if I plug 2 into my equation, the absolute value of 2 is 2. And that gives me my y value. So if I plug 1 in for x into my equation, I get the absolute value of 1 is 1, the absolute value of negative 1 is 1, and the absolute value of negative 2 is positive 2. So then I have to graph this. So I have 1, 1, 2, 2, negative 1, positive 1, negative 2, positive 2, and now I can make my V shape. Whoops. And of course, for my V shape, I would be using my ruler to connect the points. So maybe I should use a straight line. So that would be one side of my V, and this gives me the other side of my V shape. And that's what your graph should look like. So in this case, notice that the V, or the vertex, is the lowest point of my graph. So that means the vertex here is a minimum value. If I did not get that V shape out, that means that I did something incorrect, and I would look at my vertex. Maybe I found the wrong vertex, or I'd look at the points that I plugged into my equation. Maybe I made my table wrong. So let's go ahead and look at graph number 2. So looking at graph number 2, we again first want to find our vertex. So I'm going to use the equation y equals absolute value of mx plus b and plus c in the outside. So now for this equation, my m is 1 because in front of the x we have a 1, we just don't write it. My b, we don't have 1, so it's 0, and my c now is equal to negative 5. So my vertex, the x coordinate to find it, I do x equals negative b over m, which in this case is negative 0 over 1, which is just equal to 0. My c value is negative 5, so my vertex in this case is 0, negative 5. So that's the first thing I'm going to plot. So 0 down 5 would be right here. And then I'm going to put that in my table. So now I want two x values to the right of 0 and 2 to the left of 0. So 2 to the right would be 1 and 2. To the left would be negative 1 and negative 2. Now to find the y coordinates, I plug the x values into my original equation and solve for y. So if I plug 2 into my equation, the absolute value of 2 is 2, and 2 minus 5 gives me negative 3. If I plug in 1, the absolute value of 1 is 1, and 1 minus 5 would give me negative 4. And I forgot my negative on my vertex right there, so I'm sorry about that. We got to put the negative 5 there. So then if I plug negative 1 into my equation, the absolute value of negative 1 is positive 1, and 1 minus 5 gives me negative 4. If I plug negative 2 in, the absolute value of negative 2 is positive 2, and 2 minus 5 gives me negative 3. So now all I have to do is graph this. So I have 1, negative 4, 2, negative 3, negative 1, negative 4, and negative 2, negative 3, and then I'm going to draw my V shape using my ruler. And again, if I didn't get a V shape here, then I know I would have plotted my graph wrong. So let's go ahead to the next one. So for the next graph, it's the same thing. So I first want to find my M, B, and C. So my m's a value of 1, my b's negative 5 now, and my c is 0 because there's nothing on the outside. So to find my vertex, I use the formula x equals negative b over m, which in this case would be negative 5 over 1, which is equal to 5. And my c value is 0, so my vertex is 5, 0. So I'm going to put that on my chart in my graph. So 1, 2, 3, 4, 5, 0 would be right there. So then the next thing I want to do is pick two x coordinates to the right of 5. So after 5 comes 6 and then 7. To the left of 5 would be 4 and 3. So if I plug 7 into my graph, the 7 minus 5 gives me positive 2, and the absolute value of 2 is 2. If I plug in 6, 6 minus 5 is 1, the absolute value of that is 1. If I plug in 4 to my equation, 4 minus 5 is negative 1, the absolute value of that is positive 1. If I plug in 3, I would get 2. So then if I graph this, I have 6, 1, 7, 2, and 4, 1, 3, 2. So now I get my ruler and I'm going to connect the dots and make my V shape. Notice how I always use the entire graph that I'm given, and I put arrows on the ends of my lines that I have, so you should be doing that as well. So the next equation we have is y equals the absolute value of x plus 3. So again, I'm going to do the same thing I was doing for the other ones. My m value is 1, my b value is 3, c is 0 because there's nothing on the outside of my absolute value. So now I want to find the x coordinate of my vertex, negative b over m. So in this case, I have 3 over 1, which is equal to 3. So my vertex is negative b over m, which we found to be 3, comma c, which is 0. So I'm going to plot that on my graph. So 0, 1, 2, 3. Oh, whoops, 3, 0. What am I doing? And I forgot the negative here, so this should be negative. Ah. So it's negative 3, so this should be negative 3. So negative 3, 0, because it's negative b over m, comma c. So negative 3, 1, 2, 3, 0 would be right here on my graph. So now if I pick two x coordinates to the right of 3, negative 2 and negative 1, to the left would be negative 4 and negative 5. So then if I take the x values, plug into my equation, I'm going to get my y values. So if I plug in negative 1 plus 3 gives me 2, and the absolute value of 2 is 2. If I plug in negative 2 plus 3 is 1, and the absolute value of that is 1. If I plug in negative 4, I would get 1, and negative 5 would give me 2 for an answer. So my points would be here, 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 and here. So then again, I would take my ruler and connect the points, and that gives me my V shape. And of course, if I did not get that V shape, then again, I would say, did I do my vertex wrong, or did I plug in any of my points wrong? All right, so let's go to the back side. So on the back side of my paper, now notice that we have a negative in front of our graph right here. So you're asking yourself, well, what's that negative going to do to my graph? The negative is going to make your V shape open upside down. So this makes V shape open downwards. So I still want to find my vertex. So my m value is still what's attached to the x on the inside of your absolute value bar, so 1. My b is 0. My c is 3. So my vertex, x equals negative b over m, which in this case would be negative 0 over 1, which is just 0. And my y coordinate is 3, because that's your c value. So I have 0, 3. I'm going to plot that on my graph, 0, 1, 2, 3. So then the next thing I want to do, pick two x values to the right of 0 and then to the left. So 0, 1, 2, and negative 1, negative 2. If I plug 2 into my equation, the absolute value of 2 is 2, but I have that negative in front now, so it's negative 2 plus 3, which would give me a value of 1. If I plug 1 into my equation, I would get the absolute value of 1 is 1, and then we have the negative in front, so negative 1 plus 3 is 2. If I plug in negative 1, the absolute value of that is positive 1, and then the negative in front gives me negative 1 plus 3, which would be 2, and then 1. So now if I graph this, I have 1, 2, and 2, 1. And then the other side of my graph would look like this. And then of course I would take my ruler and I would connect the points using my ruler. And now I have my V shape. And so in this case, instead of having a minimum value, since it's the highest point on my graph, now this is a maximum vertex. And for the last equation, let's go ahead and do this one as well. So we have our m value is equal to 2, b is equal to 4, C is equal to 7. So the vertex x coordinate negative b over m, which is equal to negative 4 over q, which is negative 2. Now I'm going to make my vertex coordinates, negative 2 comma 7. So that's my vertex. So I'm going to put that on my chart here, negative 2, 7. So my graph's opening up, so it's going to actually go into my graph above it, but that's okay. So to the right of negative 2, we have negative 1 and 0. To the left, we have negative 3 and negative 4. So then if I plug 0 in for x, I get 2 times 0 is 0, plus 4 is 4, and the absolute value of that is 4, plus 7 is 11. If I plug in negative 1, negative 1 times 2 is negative 2, plus 4 is 2. Absolute value of that is 2, plus 7 gives me 9. If I plug in negative 3 times 2 is negative 6, plus 4 is 2. Negative 2, sorry, and the absolute value of that is positive 2, plus 7 gives me 9, and then if I plug in negative 4, I get 11. So we have negative 1, 9, which would be here, and we have this point, and then over here, and here. And notice, what did that value that was in front of my m value do? It made my graph appear to be skinnier, and just instead of wider. So that's what my graph would look like there. And notice that the m kind of corresponds to the way your lines are sloping. And remember, when we were solving absolute value equations before, we had the positive and we also had the negative of our equation. So that's why if you look here, you'll notice that the slope of this line we have up 2 over 1, up 2 over 1, whereas the question number 5, the m was 1, and since we had the negative in front, that's why it's opening down, so we have the down 1 over 1 for our slope. So that's another thing that you can look at when you're graphing these. So now let's take a look at some equations of graphs here. So it says match each equation with its graph. So if I want to match the equation with its graph, then the first thing that I would do is I would find the vertex. So we already learned how to do that, so it should be kind of easy now. So the x-coordinate's negative b over m, so we have negative negative 1 over 1, which is just 1. My c value is 0, so 1, 0. If I look at number 2, I have again negative negative 1 over 1, which is just 1, comma, 0 for your vertex. Number 3, your b value is 0. So 0 over 2 is 0 for the x-coordinate, and then negative 1 is your c value. Question number 4, you have a b value of 0, so 0 over 1 would be 0, comma, negative 1. For number 5, you would have 1/2, comma, 0. And for number 6, 0, negative 2. So once you start practicing this, you'll be able to see that just as easily as I can. So now we have to figure out which graph goes where. So we're looking first for a vertex of 1, 0. So what graphs have a vertex of 1, 0? I noticed that C has a vertex of 1, 0, and also E. So now I need to figure out which is the correct graph. So I can pick points on my line that have grid marks and plug them in and see which one works. Or if you notice my m here is a value of 1. So notice that this one's going up 1 over 1, up 1 over 1. This one's going up 2 over 1. So I already know it's going to be E for number 1. So number 1 is E. But like I said, if you didn't know that, you could plug in points. So I would have to see if 2 is on my graph. And if I plug 2 into this equation, 2 minus 1 is 1. The absolute value of that is 1. So this graph C would not work. So let's go to question number 2. If I look at question number 2, I have a vertex of 1, 0. And notice there's a 2 on the outside there. So I know that this one is going to be, the only one other graph with that vertex would be C. So for number 2, I have graph C. If I look at number 3, I'm looking for a vertex of 0, negative 1, so I have that here, and also graph A. So notice there's a 2 in front, so I know that it's going to be graph A in this case because of my slope. And then graph number 4 would have to be graph F. And again, I can just pick points and plug them into the equation to see which one works. And then for number 5, I have 1/2, 0. So the only one that has 1/2 for the vertex is B. And then for graph number 6, we just have to have our only choice that we have left, which in this case is answer choice D. And that does it for the first part of section 2.5, graphing absolute value equations.